November 24, 1944, over Tokyo marked the beginning of a new chapter in aerial warfare. On this day, 111 Boeing B-29 Superfortresses of the 73rd Bombardment Wing launched Operation San Antonio 1, striking the Musashino aircraft plant on the outskirts of the capital. This first large-scale raid showed Japanese defenders that they faced an enemy operating in an entirely different dimension of combat. The American bombers cruised at 33,600 feet, far beyond the reach of most Japanese interceptors. Fighters scrambled to meet them struggled to climb above 30,000 feet, and those that managed to close the gap found themselves flying at the edge of their performance limits, engines overheating and fuel almost gone. Anti-aircraft guns also proved ineffective at these heights. What Japanese commanders had once dismissed as propaganda now revealed itself as an undeniable reality. The B-29 was a revolutionary weapon system unlike anything they could counter. For the pilots tasked with defending Japan, the experience was crushing. Missions against the B-29 soon became more than a tactical challenge. They became a psychological ordeal, as crews repeatedly failed to even reach their targets. The road to this moment began in June 1944, when American forces captured Saipan, Tinian, and Guam in the Mariana Islands. From these newly secured bases, B-29s could reach every major Japanese city and return safely, ending the homeland's long history of isolation from direct attack. Japanese military intelligence understood immediately that the strategic balance had shifted. The B-29 project itself reflected America's industrial scale. It cost $3 billion, surpassing even the $2 billion spent on the Manhattan Project. Each bomber carried groundbreaking features: pressurized cabins that allowed crews to operate in relative comfort at extreme altitudes, centralized fire control systems linked to analog computers, and Wright R-3350 engines equipped with turbochargers that preserved power, where other engines suffocated for air. The first B-29 to arrive in the Marianas was Jolton Josie, the Pacific Pioneer, which landed on Saipan on October 12, 1944, with General Hansel at the controls. Brigadier General Haywood S. Possum Hansel Jr. had taken command of the 21st Bomber Command on August 28, bringing his experience in strategic bombing to the Pacific Theater. Performance figures told the story clearly. The B-29's maximum tested ceiling was 4,600 feet, with an operational ceiling of 33,600 feet. By comparison, Japan's most advanced fighters were barely capable of challenging them. The Mitsubishi A6M0, Japan's most famous aircraft, rarely performed effectively above 30,000 feet in real combat conditions. The Nakajima Ki-84 Hayate, considered one of Japan's best late-war fighters, had a ceiling that looked good on paper but depended on ideal fuel and light loads, conditions that no longer existed by late 1944. Even before the November raid, the vulnerability of Japanese defenses had been exposed. On November 1, 1944, an F-13 reconnaissance version of the B-29 overflew Tokyo, the first American aircraft to appear over the city since the Doolittle raid of 1942. Japanese fighters scrambled in large numbers but failed to intercept the high-flying intruder. More reconnaissance missions followed through November, mapping industrial targets and proving that Japanese defenses could do little against aircraft operating at such altitudes. When General Emmett O'Donnell led 111 bombers against the Nakajima aircraft factory on November 24th, Japanese radar picked them up from 200 miles away, and squadrons launched to defend the capital. But the outcome was grimly predictable. The jet stream winds and cloud cover scattered American bombs. Only 48 landed near the factory. But the real lesson was clear. Japanese fighters simply could not reach the B-29s in effective numbers or condition. Those few that climbed high enough were forced to fight with sluggish controls, thin oxygen, and engines straining at their limits. The environmental conditions at these heights only added to the imbalance. At 33,000 feet, temperatures could fall to minus 50 degrees. B-29 crews working inside heated, pressurized cabins wore light gear and operated normally. Japanese pilots, by contrast, lacked proper equipment and flew in freezing conditions with limited oxygen, further degrading performance. The technical explanation was straightforward. Engines lose power as altitude increases because the air becomes thinner. The B-29's Wright R-3350 engines overcame this problem with General Electric B-11 turbochargers. which used exhaust gases to compress intake air and maintain power at high altitudes. Japanese fighters lacked effective turbochargers, so their performance declined sharply above 25,000 feet, leaving them at a hopeless disadvantage. The November 24th raid proved to both sides that the age of conventional fighter defense was ending. The B-29 Superfortress could fight and bomb at altitudes where Japanese aircraft could barely function. This was more than a new bomber. It was proof that industrial power, advanced engineering, and revolutionary technology could overcome even the most determined defenders. For Japan's pilots, the war in the skies had entered a realm where courage alone could no longer bridge the gap. During World War II, the struggle to bring down the B-29 Superfortress pushed Japanese fighter pilots to extreme measures. Interceptions at such altitudes were nearly impossible, and by August 1944, some pilots began resorting to suicide ramming attacks. In October, Japan even created specialized kamikaze fighter units for this purpose. By the war's end, these ramming tactics had destroyed 9 B-29s and damaged another 13, at the cost of 21 Japanese fighters. After the war, the United States Strategic Bombing Survey conducted a full review. B-29s had flown 31,387 missions over Japan, dropping 169,676 tons of bombs. Only 414 aircraft were lost, a rate of just 3%. Even more striking, Japanese fighters were responsible for only a fraction of those losses. Far more B-29s were lost to mechanical failures, bad weather, or operational accidents than to enemy fire. Still, Japanese pilots and engineers tried desperately to find solutions. On December 3, 1944, the 244th Sentai under Captain Teruhiko Kobayashi carried out the first organized ramming attacks, claiming 6 B-29s destroyed by direct collisions. Incredibly, all the Japanese pilots survived by bailing out after impact. Kobayashi himself, who became the youngest Sentai commander in November 1944, scored 5 victories, 3 of them against B-29s. Yet even his success relied on ramming tactics or low-altitude ambushes, not traditional high-altitude dogfights. Japan also experimented with new high-altitude interceptors. The Mitsubishi J2M Raiden was tested with a turbocharger that, on paper, allowed it to climb to 38,000 Fs. But the system was unreliable, and only 35 modified aircraft were ever produced. The Kawasaki Ki-108 was built with a pressurized cockpit, one of Japan's rare attempts at such technology. But only 4 prototypes were completed before a fatal system failure ended the program. The Tachikawa Ki-94, designed specifically for high-altitude interception, was supposed to reach 45,000 Ft with a pressurized cabin and turbocharged engine. But when the war ended, only 2 prototypes were partly finished. Fuel shortages created another massive problem. By late 1944, Japanese aviation fuel had dropped to 87 octane or even lower, compared to the 100 and later 115 octane fuel used in American aircraft. This low-grade fuel caused engine knocking and dangerous overheating, forcing pilots to throttle back just to keep their engines from failing. Combined with natural power loss at altitude, Japanese fighters could not climb or maneuver effectively at B-29 heights. Reaching those altitudes often consumed 3 times more fuel than normal, leaving pilots with only minutes of combat time, or none at all, before being forced to break off. As if that wasn't enough, Japanese pilots encountered the jet stream for the first time. These powerful winds, reaching speeds over 200 mph, were discovered by B-29 crews flying from the Marianas. American navigators quickly learned how to use them to their advantage, sometimes pushing bomber ground speeds above 500 mph. Japanese fighters, struggling to climb against these winds, seemed frozen in midair. While Japanese meteorologists had theorized about the jet stream, their Air Force lacked the equipment to study or prepare for it. In January 1945, Major General Curtis LeMay took command of the 21st Bomber Command and changed B-29 tactics entirely. Instead of high-altitude raids, he ordered low-level night bombings. On the night of March 9-10th, 1945, 334 B-29s attacked Tokyo at altitudes of just 5,000 to 7,000 Ft. This new tactic overwhelmed Japan's defenses. The city burned, with 267,000 buildings destroyed and roughly 25% of Tokyo wiped out. Casualties were staggering, around 100,000 people killed in a single night. Out of 334 bombers, only 14 were lost, most to turbulence from the massive firestorm rather than enemy action. Japan's night fighter force proved ineffective. Most pilots lacked training in instrument flying, and radar guidance was poor. By early 1945, Japan's ability to intercept at high altitudes had collapsed completely. Maintenance standards broke down as parts, tools, and skilled mechanics grew scarce. Pilot training, once 2 years long, was cut down to just 3 months, producing flyers without the skill or endurance to fight at the required altitudes. On April 15, 1945, Japan attempted to unify its fractured defenses by placing both Army and Navy air units under a new Air General Army commanded by General Masakazu Kawabe. But by then the fighter force was broken. Even elite formations like the 343rd Naval Air Group, formed in December 1944 under Captain Minoru Genda, with Japan's surviving aces, could do little. Physics itself was against them. Japanese aircraft simply could not operate where the B-29 thrived. The final blow came in April 1945 when P-51 Mustangs began escorting B-29s from Iwo Jima. On April 7th, a major raid on Tokyo saw P-51s from the 7th Fighter Command claim 101 Japanese aircraft shot down, while losing only 2 Mustangs and 7 B-29s. From this point on, Japan's skies belonged entirely to the Allies. By late 1944, only 20% of Japanese aircraft that managed to get airborne even reached the main bomber formations, and of those, many failed to attack any target at all. The combination of altitude, technology, fuel shortages, and the introduction of long-range escorts sealed Japan's fate in the air. By March 1945, American bombing accuracy had improved dramatically. 85% of B-29s were striking their primary targets, and by July that number rose to 94%. This leap in effectiveness came not only from better tactics, but also from the near elimination of Japanese fighter resistance. The ultimate proof of altitude superiority came during the atomic bomb missions. Training flights by the 509th Composite Group took place at 30,000 RFT, safely beyond the reach of most Japanese anti-aircraft guns. Japanese fighters did not even attempt to intercept. On August 6, 1945, the Enola Gay released the first atomic bomb on Hiroshima from 31,600 FO. 3 days later, on August 9th, Boxcar dropped the second bomb on Nagasaki from 28,900 RFT. Both missions went unopposed, as Japanese aircraft simply could not reach them. The very last air battle of the war reflected the confusion inside Japan's air defenses. On August 18, 1945, 3 days after Japan's surrender, ace pilot Saburo Sakai flew in the Navy's last mission. Attacking 2 reconnaissance B-32 Dominators he mistook for B-29s. The clash took place at $6,000 or roughly 20,000 FT. Sakai quickly noticed the single tall vertical stabilizer, unique to the B-32. During the fight, Sergeant Anthony Marchione was killed, becoming the last American combat casualty of World War II. Every B-29 carried technologies Japan had not mastered. These included constant speed propellers with electric pitch control, turbo-supercharged engines, centralized fire control guided by analog computers, and fully pressurized cabins with heating and cooling. The industrial gap between the US and Japan was not measured in years but decades. Each B-29 needed over 13 tons of aluminum, half a ton of copper, 600,000 rivets, 912 miles of wiring, and 2 miles of tubing. While Japan still relied heavily on hand-built aircraft by skilled craftsmen, American factories mass-produced B-29s with standardized assembly line methods. By October 1944, the 21st Bomber Command had grown to 43,000 personnel spread from Colorado Springs to the Mariana Islands. This immense organization highlighted U.S. logistical power, just as the B-29 itself highlighted technological superiority. By August 1945, that combination had shattered Japan's economy, crippled its industries, and broken civilian morale. The bombing campaign unfolded in phases. Between November 27th and December 3rd, 1944, Tokyo was attacked 3 times. 2 raids hit the Musashino aircraft plant, while the third used M69 incendiary clusters against an industrial district. On February 25, 1945, 172 B-29s destroyed 28,000 buildings in a single incendiary raid. On April 2nd, more than 100 B-29s struck the Nakajima aircraft factory, and on April 7th, 101 bombers hit it again. By April 13th, over 300 B-29s were hammering military sites around Tokyo. The raids devastated Japan's ability to fight. Aircraft plants were repeatedly destroyed, crippling production and preventing replacement of combat losses. Oil refineries were targeted until aviation fuel production was nearly gone by mid-1945. Transportation strikes against rail yards and ports paralyzed supply movement. Urban firebombings reduced entire neighborhoods to ashes. On May 25, 1945, 464 B-29s bombed Tokyo's Yamanote area, killing 3,352 people and destroying 166,000 buildings. Even Tokyo Station and parts of the Imperial Palace were damaged. The B-29's altitude advantage was never about one single breakthrough. It was the combination of multiple technologies. Turbochargers, such as the General Electric Type B11, used exhaust gases to maintain engine power in thin air. Pressurization systems kept cabin altitude at 8,000 ft, even while cruising above 30,000 ft, allowing crews to operate without oxygen masks. The Wright R-3350 duplex cyclone engine, with its 18 cylinders in 2 rows, generated 2,200 horsepower with turbocharging, something Japanese engines could not match. The centralized fire control system, using analog computers, let gunners coordinate multiple turrets and calculate lead angles automatically. Japanese pilots found this defensive network lethal, especially since their only approach was usually from below, where accuracy was highest. Yet technology was only part of the story. The courage of Japanese pilots deserves recognition. They climbed until their engines overheated, until ice formed on their wings, and until oxygen deprivation blurred their vision. They knew they might never even reach the bombers, yet they tried again and again. Over time, their repeated failures became a psychological blow to the entire nation. Civilians could see B-29s passing overhead, high above their defenders who often returned without ever making contact. The sight itself carried immense psychological weight. As the war dragged on, Japan's pilot training system collapsed. Instead of 2 years of instruction, new pilots received barely 3 months, entering combat with less than 100 flight hours. By contrast, earlier Japanese aces had trained with 500 or more hours before facing combat. The imbalance in training, technology, and resources sealed Japan's fate. By the summer of 1945, the B-29 was not only an unstoppable weapon, it was a symbol of America's overwhelming industrial, technological, and organizational power. During the final year of the war, Japan relied heavily on inexperienced pilots. These novices were not trained for high-altitude operations, which made intercepting American bombers nearly impossible. At the same time, Japan's maintenance crisis worsened. By spring 1945, aircraft readiness had dropped below 40%. Advanced high-altitude fighters required careful upkeep. But with parts, tools, and skilled mechanics in short supply, many aircraft failed in combat. Engines often quit during climbs, and pilots sometimes died trying to escape planes with jammed canopies caused by poor maintenance. The B-29 campaign proved effective for reasons far beyond the tons of bombs dropped. Because the bombers flew higher than Japanese fighters could reach, they carried out a wide range of missions almost unopposed. Daylight precision attacks continued despite jet stream winds reducing accuracy. Later, low-altitude night incendiary raids burned Japanese cities on a massive scale. B-29s also dropped thousands of naval mines that blockaded Japan's waters, carried out leaflet drops that crushed civilian morale, and performed reconnaissance flights that mapped defenses with ease. The bombers' impact went far beyond the atomic strikes. Emperor Hirohito's surrender speech mentioned a new and most cruel bomb, but leaders had already admitted that B-29 raids made defense impossible. At the Imperial Conference, Japanese commanders confessed they could no longer prevent the destruction of their remaining cities. The atomic bombs became a reason to justify surrender, but conventional raids had already forced defeat. Civil officials like Utaka Akabane later explained that it was the firebombing of medium and smaller cities that broke public morale most severely. By August 1945, Japan's industrial output had collapsed to less than 15% of its wartime peak. The B-29's altitude advantage carried lasting lessons for strategy. Controlling a domain your enemy cannot reach provides a decisive edge. The bomber's ability to operate 15,000 to 18,000 feet higher than Japan's fighters foreshadowed modern concepts of air superiority. Success came from combining technology, pressurized cabins, turbo-supercharged engines producing 2,200 horsepower, centralized fire control, and advanced navigation into one powerful system. Equally important was America's industrial strength, which built nearly 4,000 B-29s while maintaining quality standards. Training also mattered. U.S. crews received extensive preparation to handle the aircraft's complex systems, which allowed them to use the bomber effectively. The B-29 campaign reshaped aviation worldwide. The Soviet Union reverse-engineered captured B-29s into the Tupolev-24, emphasizing high-altitude performance in later bombers. The need to intercept these bombers pushed jet fighter development and led to the creation of surface-to-air missiles. Decades later, former Japanese and American airmen met at reunions. U.S. crews praised the bravery of Japanese pilots who tried hopeless interceptions, while Japanese veterans admitted they knew by early 1945 that their efforts were futile, but pressed on out of duty. For Japan, the trauma of being unable to reach the B-29s shaped its post-war defense priorities. Every new aircraft design demanded strong high-altitude performance. The altitude gap, about 3 miles, meant the difference between protecting the homeland and watching helplessly as it was destroyed. Japanese pilots moved through stages of disbelief, denial, desperate attempts to adapt, and final acceptance of technological inferiority. For the Americans, the B-29 confirmed the theory that strategic bombing could be decisive. Operating above enemy defenses turned bombing from a costly battle of attrition into systematic destruction with minimal losses. With only 1.3% losses across 31,287 sorties, the B-29 became the symbol of American industrial power, engineering skill, and strategic dominance, factors that helped bring World War II to an end. Submarine warfare had already crippled Japan before the B-29 even arrived. American subs cut off vital shipping routes, leaving factories without the raw materials they needed. At the same time, U.S. codebreakers tracked Japanese fighter deployments, allowing B-29 missions to avoid the heaviest concentrations of defenses. Industrial power also played its part. America was not just building advanced bombers. It was training crews, supplying forward bases, and showing a level of organization and production capacity that Japan could not match. The B-29 raids were never a standalone effort. They were part of a wider plan that hit Japan from every angle. The altitude advantage only amplified these other efforts, speeding Japan's collapse. The B-29 was more than just another bomber. It marked a turning point in aviation history. This aircraft showed that complex machines could be mass-produced, maintained, and flown in combat with reliability. Its power came not from one single feature, but from a combination of technologies: pressurized cabins, turbo-supercharged engines, centralized fire control, and advanced navigation. Integration mattered more than individual skill. For the first time, large-scale production of complex systems replaced the old reliance on pilot courage alone. Technology had become decisive. For Japanese pilots, the shock of watching B-29s cruise beyond their maximum ceiling was more than a tactical problem. It shattered the belief that spirit and determination could outweigh material disadvantage. Japan's military had built its confidence on the idea of spiritual superiority, but the B-29 proved that belief dangerously wrong. Within just 9 months, the U.S. bomber force expanded from a single wing of 119 aircraft to 5 wings with more than 1,000 B-29s. From their new bases in the Marianas, these bombers systematically destroyed Japan's war economy while suffering minimal losses. Statistics alone cannot capture the human cost. Thousands of Japanese pilots launched missions knowing their chances of success were nearly zero. They climbed until engines quit, until oxygen ran out, or until their aircraft spun out of control, helpless to stop the bombers overhead. Trained in traditions that valued courage above all else, they discovered that bravery could not overcome physics. Determination could not make an engine perform at 33,000 feet on poor fuel. Spirit alone could not climb to meet the enemy. The B-29s symbolized something greater than just American air power. They represented the triumph of industry and technology over authoritarian ideology. Museums today tell this story clearly. The sheer size and complexity of a B-29 compared to the simplicity of Japanese fighters. The lesson was unmistakable. Industrial methods and advanced systems had replaced traditional designs and warrior culture. Modern militaries continue to study this campaign as a model of asymmetric advantage. When one side operates in a space the other cannot contest, whether in altitude, space, or cyberspace, traditional strengths no longer matter. The moment Japanese pilots realized they could not reach the B-29s was also the moment the Pacific War's outcome became inevitable. This was not just about bombs dropped from the sky. It was about the dawn of a new kind of warfare. Technology had become the deciding factor. Industry had overtaken ideology, and physical limitations had exposed the limits of courage. The B-29 campaign showed that victory belongs not simply to those willing to fight hardest, but to those who can operate where the enemy cannot follow. For the young Japanese pilots who tried to intercept, it was a tragic experience. They fought with bravery but faced a battle already lost to engineering and industrial power. For the Americans, the B-29 stood as proof that advanced technology and mass production could win wars. In the skies over Japan, as B-29s flew far above the reach of defenders, the old world of warrior tradition gave way to the modern age of industrial warfare. It was in those unreachable altitudes that the future of combat was written.